Let's roll here. It's method 25. My name's Andy. I'm a sophomore at the University of Washington, and this is my video about on method 25 part 2. Today we can talk about section 5.3, which is the fundamental theorem of calculus. Fundamental theorem of calculus. And what is the fundamental theorem of calculus? There are two parts of called this FTLC. In part one, it is we define like the area under the other curve is antiderivative. Is antiderivative so let's definitely define the derivative of the area was like the area it is. Yep. So defines like dx over there's like a region of f of x dx is the function itself. So it's like for any constant a, the accumulative sine area the accumulative sine area formula, it is antiderivative it is x to a f of t dt. So this is like the area between is like the area under the curve. So now what we're going to do is to find the derivative of a function. So let's do an example here. Perhaps we have a function. It is g of x is equal to x and 0 is 1 and 1 plus t squared and to the dt. And according to the part one, the derivative of this part, it is just function itself, but just to substitute the variables as t to s. So the g prime of x. So we just say according to FTOC, number one, g prime of x, it is equal to 1 plus x to the squared. This is only just part one of like the fundamental theorem of calculus. Let's do another one. If h of x is equal to then find h prime of x. Try this question on your own. Perhaps it is on the exam. So according to part one, this is still part one. Let me say, according to the h prime of x, it is cosine of x. Here's a simple trick. Here's a simple trick. It's like if the given function has constant or the variables just power is 1, then the derivative is the function itself but changing the variable is x. And now let's do some like more advanced example here. So it's gonna be example number 3. If we have f of x again, it is equal to perhaps it's a -8 and x t times et and dt. Find f prime of x. Maybe pause the video, try this on your own, perhaps it is on the exam, or maybe solve this problem. And first we see there's a negative values on the top, so we need to swap the bound first. And now, according to FTOC part 1, And we have it is I have prime of x, it is negative x e to the x. Also make sure to swap the bound. And then let's do like another example here. Here's a trick. So if you see a negative value on the top of the integrand, just to swap the bound and then just evaluate. Integrand. Usually swap the bound is the first step. Adding a negative sign. Let's try another example. This is a harder, but it's just doable. So perhaps, for example, here. And then what we have it is, if we define k of x is a function, it is equal to x to the fourth and a 0 t plus cosine of a t to dt. Find k prime of x. Maybe pause the video, try this on your own, perhaps it's on the homework or the midterms. We might should chain rule to solve the derivative this time. Use the chain rule. The u equal to x to the fourth. Then du equal to 4x to the cubic. Then when we have the k prime of x, it is equal to have a u and a 0 t plus cosine of a t dt. And by chain rule, we have is this du, and inside is u and the 0 t plus cosine of a t dt. Then we have du and dx, and which is same as 4x to the cubic. Then what we have it is cosine it's just gonna be u plus cosine of u and du dx. Forgot this. Then the k prime of x, it is x to the fourth, and then plus cosine of x to the fourth, multiplied by 4x to the cubic. Here's the k prime of x, the derivative. And maybe try another example here. Example number 5. If m of x is equal to, okay, so let's say it is x to the 10th and the 2, secant of x, no, t, secant of a t and a dt, find m prime of x. I might be pause the video, try to solve the problem on your own, perhaps it is on the exam. We have used the chain rule again. And then we need to do it as here's k prime of x. It is 2 and the u. It is secant t to the dt. And then what we have it is du, u and 2, secant of a t and dt, and then we multiply by du and dx. For this side, and we have it is just this secant u times the du dx. Finally, we have this m prime of x. I'm so sorry for the mistake. It's gonna be secant to the x to the 10th times 10x to the 9th is our final answer. Now this is gonna be like a hardest part of FTOC right now. So if we have two polynomials or functions on the integral, then how do you solve the problem here? So we call it FTOC part 1, but it's advanced. Dx of h of x, g of x, or ft/dt. It is equal to f of h of x h prime of x minus f g of x, then multiply by g prime of x. Then we use the chain rule and then separate. So this is applied to both terms on the integrand are polynomials or functions. Now let's do an example here. If we have a function, I forgot page number, it is 15. Just to check everything is here. You can see me, right? Example number 6. If we have a function, it is f of x. It is equal to x to the fourth, the 1 plus x to the 1 plus x to the squared. You have 4 plus t and a dt. I need to find f prime of x. Or maybe pause the video, try that around. Perhaps this is on the exam. Then we need to, because it's cross like a 0, so we need to write it into 2 integrals. Or like the function f of x equal to 1 plus, it is going to equal to a 0 on the top and 1 plus x to the squared, 4 plus t to dt, and the plus from the fourth and a 0. It is 4 plus t dt. Here's a function number, and remember we always function just on top, so we do like a swap or the bond. And we do a swap, it is going to be negative 1 plus x to the squared and the 0, 4 plus t dt, and plus x to the fourth and the 0, 4 plus t and dt. It is radicals. Now use the chain rule. We put inside function as h of x. So it is 4 plus, so this is gonna be 4 plus 1 plus x to the square, and for this is h of x. For g of x, and we put another function here, put t as x to the fourth. Then what we have is, it is 4 plus x to the fourth use the chain rule here. Don't forget the chain rule and take the derivative. It is going to be 2x. And then plus the 4 plus x to the fourth. The derivative is 4x to the third. 4x to the cube x. And now it's getting easier for part 2 of FTLC. It is much more easier. FT part 2. It is and definition it is if f of x is continuous on an interval a and b, then the area under the curve then do you like the definite integral equal to big F minus big F of A. F is any antiderivative of f of x. It's a capital F for x. It is the antiderivative of f of x. This is also expressed at the area under the curve. F of x from x equal to a to x equal to b. For example, here, evaluate the integral this one we are going to try to just do like the general antiderivative, and what we have it is 1 to the third x to the cubic 3 and the 2 is equal to 0.9 minus 8 over 3. It is 19 over 3. And let's do another example. Let's do example number 8. Evaluate the integral try to pause the video, try to evaluate the integral on your own. Perhaps it is on the homework or the exam. What we have is just and we rewrite them into like 4 different integrals. minus 4, say, squared, and we just evaluate them. Minus 4 arctan of x 2 and 0. Then we have the 2 to the 4, it's a 4 minus e2 minus 1. I mean plus 4, and you minus arctan 2 minus plus like a 0. Then we have is 509 minus 4 inverse tangent of x is our final answer. Let's do another example here. Example 9. Evaluate the integral. For this one, it is the antiderivative of like a natural log. So we just evaluate the integral. It is equal to the natural log of x and the 1. So it's natural log of 10. Because natural log of 1, it is a 0. Number 16 is not example. We do example number 10. Find the area under the curve f of x equal to 3x squared minus 4x from plus 4x from x equal to a 0 to x equal to 4. Maybe try this example on perhaps it is on the exam. The area under the curve. It is b and a f of x and dx. Now it's b equals to 4 and a equals to a 0. Then what we have, it is, and 0, this is function is 3x to the squared and the plus 4x dx. And then just evaluate the integral. Have it as x to the cubic, 4 and 0, and plus a 2x to the squared, 4 and 0 is 96. Then that's all for fundamental theorem of calculus. Next video gonna be section 5.4, which net change theorem, and it's more kind of evaluating the integral strategies. Thank you guys for watching. Have a great day.